Hello again. I'm going to continue my talk about the visual field interpretation. Today I will finish the single field analysis. My talk today will be about the visual field indices, which are the global indices, the mean deviation and pattern standard deviation, and the visual field index and the glaucoma hemifield test. I will start by global indices, which are the mean deviation, the normal value between +2 up to -2 decibel, the pattern standard deviation, and the short-term fluctuation SF, the normal up to 2 decibel, and corrected pattern standard deviation, the normal up to 4 decibel. The main deviation, as I explained in the previous presentations, it is the average of the decibel deviations of the measured threshold value from the normal matched value. It represents the height of the field. The average of all these decibel deviation is the main deviation. It presents in a number, only one number, which indicate to generalized depression of the visual field. Can be affected by the cataract and refractive error and the situation of the pupil, if it's constricted or if it is dilated. We can see here, the yellow line. It is the normal hill of the vision. You can see there is or equal depression in all of the visual field, which is the gray hill of the vision. The difference between the yellow line and the gray hill of the vision, it is the main deviation. The normal value, as I said, the +2 up to -2 decibel. It is a +2 when the measured threshold values are higher than the normal age values, and it is -2 or negative when the measured threshold values are lower than the age matched control values. The pattern standard deviation, it shows the shape of the visual field and indicates to a local defect in the visual field. We can see the hill of the vision, normal one, by the red color, and you can see the shape of the measured visual field by the blue color, and you can see it is irregular, and this irregularity represented by the number, it is the pattern standard deviation. The pattern standard deviation measures the irregularity. How? Measure the irregularity by summing the absolute of the difference between the threshold value for each point and the average visual field sensitivity at each point. Average visual field sensitivity at each point, it is equal the normal value plus the main deviation. And the pattern standard deviation presents by a number. If this number is high, it indicates a deep and local defect in the visual field. And when this number is low, that indicates the visual field either normal or there are severely damaged visual field, and at that time we will shift to the main deviation, and I will explain all this later in the systematic approach of the visual field. Now the short-term fluctuation, it is the difference of the responses at the same location, at the same point, in the same session. That means they give you sensitivity, a threshold value at this point, and in the same session the machine retests this point and give you another sensitivity threshold value, and it is normal when the short fluctuation less than 2 decibel, and it is less than 3 decibel in early glaucoma and less than 4 decibel in moderate glaucoma, and it is higher than that and increases in advanced glaucoma. However, the short-term fluctuation SF does not appear in the theta strategy. It is appeared in the old strategy, which is the full threshold. Also, the corrected pattern standard deviation, it is the pattern standard deviation corrected from the short-term fluctuation. That means the value of the pattern standard deviation deducted by the short fluctuation, and also indicates to localized visual field defect, and also doesn't appear in the theta strategy, and it is presented in the old strategy, the full threshold. Now the visual field index. This index is designed to better evaluate the rate of the progression, which I will also talk about it later. It is calculated as percentage of normal visual field, is presented like a percentage, not a number. And after adjustment for the age, the visual field index of 100% indicate completely that the visual field is normal, and the visual field index of 0% indicates that there is a perimetrically blind visual field. So the advantage of the visual field index comparing with the mean deviation, the mean deviation is affected by the cataract, whereas visual field index is not affected by the cataract, and the visual field index is more sensitive to the changes near the center of the visual field in order to better correlate with ganglion cell loss. Now the glaucoma hemifield test, it is very important to evaluate. This is index. It is a mirror image analysis of each of 5 pairs of zone. These zones, as you can see, zone 1 and 2 and 3, 4, 5. These 5 zones are compared with the similar 5 zone in the other hemifield, and it is used only for glaucoma, and it is an accurate method for glaucoma detection along with other indices, and it's very important to look at the glaucoma hemifield test while evaluating the glaucoma visual field. So the glaucoma hemifield test is presenting in the single field analysis like outside normal limits, which at least one zone pair differs by fewer than 1% of normal subject, and borderline, where also at least one zone pair differs by fewer than 3% but more than 1% of normal subject, and generalized reduction in sensitivity and abnormal high sensitivity. Here the best test point locations, best sensitive parts, are so low or so high as to be at levels seen in less or equal 0.5% of normal subject, and presents as within normal limits. So you can see in the printout outside normal limits, borderline, within normal limits, or generalized reduction in sensitivity or abnormal high sensitivity. Next presentation, I'm going to talk about a systematic approach of the visual field. I will talk about the quality or reliability of the visual field test and how to assess the normality and abnormality of the visual field, along with how to identify the artifacts. And thank you for listening.